Hello guys, and welcome back to the third video in our C++ programming for absolute beginners course. Now, in this video, we're going to be going over different things we can do with numbers in C++ programming language. So, I'm going to head over to Repl.it as always, click on New Repl, and always select C++, and we're going to name today's Repl Working with Numbers. Or we can just say numerical operations in C++. So like different things we can do with ints and floats in C++. And once this loads up, I'll tell you guys what to do next. Now once your rep loads up, you're just going to hit over here. Because if I click on this button, it will show me the files that I have in this REPL. We can just hide it like that. Now, as always, we're going to go ahead and do using namespace std. As always, don't forget your semicolon. And let's get started. So first, we're going to create a variable, and we're just going to call it num1. We're just going to call it x. And we're going to make it store the number 5. Going to make another one called int y, and it's going to store the number 7. Now, we have two numbers over here. We have two variables that are storing, we have two ints, so ints. We have two variables that are that store an int, so they're variables that are storing int data types, right? As always. So you can just call a variable, you can just say the type of the variable and refer to that when you're talking about variables. Generally, you would do that. So we've just created two ints, two variables, x and y, and they're both storing two ints. So we can do different things with numbers in C++. So the first thing we can do is, first we're just going to print out x and y. As always, we can print out variables to the console. And if you want to print out multiple things to the console using the cout function, we'll get into what functions are later, but just bear with me. Using the cout function, we can print out multiple things in the same line, so the same printing line, by just adding another pair of less than signs, which I explained earlier. And so we get 57 because they're right beside each other, and we can also add a next line character. As I said, next line character looks like a \n. Just do this. So what this printing function will do is it will print out x, this variable, and then it will print out a next line character denoted as a \n, and then it will print out y. So we can see 5 on one line and then 7 right underneath. And as you can see, that's what happened. So we can actually do a little bit of arithmetic in C++. So we can add numbers together. We can say x plus y, and what do you think the output of this code will be? Pause the video and tell me. Now, if you've come back from pausing the video, we're going to, I'm going to tell you guys the actual output. So, as always, I told you guys before, the variable name will be, the computer will look at the variable name and then look at the value. So, literally what we're doing here is we're looking at x, well, it's equal to 5, so 5, and then looking at y is equal to 7, and then we're doing an operation, we're doing addition. So if we just type in the addition character in our keyboard, we can add two different variables or numbers together. And literally what this line of code is doing, x plus y, it's just the same as 5 plus 7, because they're just, as variables, they're just being referenced by variable names because we're using variables to add these together. First, we can multiply x and y. In this case, we're going to be adding, first we can add x and y. In this case, we'll be adding 5 and 7 together, and the output should be 12. As you can see, we can add different things. I can put whatever kind of number that I can. Just don't go over, don't be like crazy with the decimal digits, because it will, if it's above the amount of memory that we're capable of having, then it will just not, it will not perform the arithmetic error. It will not perform the arithmetic operation, and will just give us it'll just give us an error. It will either tell us that, directly tell us that there's not enough memory or RAM in our system. So yeah, just stick with a number that's like fairly big. So like stay until 1,000,000. Okay, that's fine. 1, 2, 3, 4. So roughly a number that looks like this, or you can just go over until it tells you that the number is too big. So we can just put like some crazy numbers. The point that I'm trying to make, we can put a crazy number, and the computer will still execute this. Will still add it together. As you can see, if we even put this in our calculator, it's correct. So calculators would be using programming languages in order to do arithmetic functions. So next thing we can do is we can subtract x and y. So we can subtract this number over here by this number. Let's just say 12 minus 7, which would give us the difference of 5. As you can see. And also we can do the same with negative numbers. So even if I make this negative and say went back to adding, it would still work. And even if we did subtraction, it would still work. So you can do whatever you want with ints, because ints, as always, can either be negative or positive, so as floats, except they have decimal points. Alright, they can also be negative and positive numbers. So you can do subtraction, and let's try some multiplication. So let's do 9 times 9, which should be 81. And the character we have to put for multiplying two different things, two different variables, or two different numbers, is we need to put an asterisk. Now the asterisk denotes multiplication. So when you put in the character of an asterisk, it will multiply x and y together, in this case 9 times 9. Alright, 81 is always any number that I want, so I can just do something like this. Okay, and typically what you want to do is, when we're doing arithmetic or math-based operations, we're trying to involve some math, or we're trying to do some calculations in our programs, is we want to do another include. We want to include something called CMath. Now, I'll get into what includes are later, but just to give you a brief explanation, what includes do is they get us code from other files or other things that people have already made. So this include CMath itself is a file that someone made, and basically what CMath allows us to do is it's like a package. So we get to take these packages from other people's work, and we get to just use them. So we get to use the different things that they have in that file. We can just use whatever code that they have in these files in order to write and include them in our files in order to access whatever they have in our own programs. So basically what you want to do when you're doing some calculations or mathematics in your C++ programs is you want to do this little hashtag include CMath. And as always add the hashtag include IOStream, because what this allows us to do in C++ is, this is like the default. You need to have included the IOStream library. If you don't have IOStream, then you cannot run or compile C++ code. It's essentially like the head library that needs to be there. So you'll always be having IOStream, you'll always be having int main, and using namespace std is not necessary, but these are necessary. You need an int main to execute everything in your code, and I'll get into what namespaces are later, but using namespace std is just makes things a little bit easier. It's not necessarily mandatory to have. So we're just going to include this little CMath, and what this little package, so we're going to call it as packages for now. What this little package does is it allows us to do different calculations. So you can do like different things, which I'll get into later. So now that we have the math package imported, we can use its different functions and tools that it has, or its different pieces of its code in our own file. So we can multiply to ints or any kind of number. We can even do this with floats. We can also divide. So for dividing, I'll show you guys another operation to like end off with explaining to you guys the different arithmetic operations we can do. So how do we divide two different numbers? Well, we can just add a little slash like that, front slash. Backslash would look like this, front slash would look like that. So a forward slash basically is what division looks like. Basically what we're doing is we're finding the quotient. We're doing 9 divided by 9,123. And do you guys think this output would actually give us the correct quotient if we actually run this code? Well, if you said that it does, well, you're wrong, because you wouldn't have known this since you're new, right? Well, not because I have to explain to you guys, right? So you wouldn't have known this, but when you do division in using two ints, you wouldn't get the actual value. So specifically for division, you can't really do it with two ints, or else it's going to round the float number. So in case of my output, so if I did 9 divided by 4, so let's just give it a test. If I did 9 divided by 2, the answer would be 4.5. But since these are two ints, and we're dividing two ints by each other, so the types are very important when you're stating numbers, which is either floats or ints. So when I'm dividing two ints together, even if the output, so in this case 4.5, even if it's a float number, which will be the output, it would round that using the rounding rules. And what do the rounding rules say? Well, you guys obviously know, which is 4 and below goes down, and 5 and up goes up. So we'll look at this tenths place and then round up 5 to be, instead of being 4.5, it will give us something like 5.0. So if I run this over here, and essentially what this two backslashes is, it's called a comment. We'll get to that later. I won't really explain that. So we're just going to run it. And as you can see, the output should be 4.5, but instead it gives us 4. Now, I said that it would use rounding rules, but in certain cases it would just give the number of the, oh yeah, so it wouldn't use the rounding rules because we know that it knows that it wants the actual quotient of 9 divided by 2, which is 4.5. So forget about that, my bad guys. So instead of it rounding it to 5, it would give us 4 because it knows the forward number, but it gives us type int. So it wouldn't round necessarily this, but since we're doing it between two ints, it would give us an int value. And why 4.5 is a double. So to the computer, it would be like, well, we're doing this between two ints, so just right over here is a double. Now, since we're doing this between two ints, it would have to give us the sort of, you know, and I'm saying this in quotations because it's not really like for us accurate, but for the computer, it's sort of like this. So I'm metaphorically speaking. So it sees that the output would actually be 4.5, but it also sees that we're doing division between two integers, and it knows that if the output is double, it would have to change it to an int because it's dividing two integers together, two numbers of type int, two variables of type int, and it sees that it's 4.5, but then it needs to always remove that decimal place in order for it to be an int. So to the computer, if we're dividing between ints, it will give us an int value. If we're dividing between floats, it will give us a float value. So that's just the rule with division. Always make sure that your types are different. So if I want to get the correct answer, then I would just need to change 1 to double. I could either change one of these doubles, but I would have to change 1 to double. So if you want to get the precise values of an integer divided by another integer, you would just say that integer with a 0.0. So in this case, I would just change y to a double 0.0, and we should get 4.5 over here. So it's basically saying, oh, I don't want this 0.5, so it removes that 0.5s and gives us it removes that 0.5 in the 4.5, and it just gives us a 4 because we're doing between two ints. So always remember, for division, the rules apply, and the rules in this case is when you're dividing an int by another int, and you know from, like, you say you already know this in the calculator, and I'm just showing you guys the program, because C++ can solve arithmetic operations, is that that when you're doing these two, you would have to change just one. So just change 1 to a double. So I can change either x to a double, or I can change the variable y to a double. In this case, we're going to be changing x to y. We're going to be changing y, and because I don't want to do 9 divided by 2.1. No, I want to do 9 divided by 2. So all I do is I change it to a double, and because of the double rules, we just add 0.0. So 9 divided by 2.0 is the same as 9 divided by 2 in mathematics, and the computer will execute this correctly. So when you're dividing by two ints, and say you already know the output, and you know that output is a decimal number, or a float, in case for the computer, then the second variable, or either one of the variables, you would have to change to a double, and since you're wanting to divide two ints, you don't want anything else, you would just add a 0.0 to the whole number that you want to divide. In this case, I want to do 9 divided by 2, so I just change y to a double, then I get 2.0. So instead of doing int x equals 9, and then int y equals 2 and then printing out c out x divided by y. Instead of doing that, we should change it to int x equals 9. Or we can do vice versa, but in this case, int x equals 9 and double y equals 2.0. In this case, if we do 9 divided by 2.0, we should get 4.5. And these are the rules for getting accurate results. So this is how you get the correct value when you're doing division between two integers. So always remember this rule. So we should get 4.5. And congrats! 9 divided by 2.0, or 9 divided by 2, we can just remove the 0.0, is 4.5, and that's the output that we get in the console. So always remember when you're dividing by 2 ints, you just change 1 to a double, and since you're doing it with 2 ints and you don't want any other number, you would just add the 0.0 at the end, and you will get the actual precise correct value. So that's division. So this only applies with division, changing the type int to double. This only applies with division. So let's move on to a little bit of other operations we can do. And we couldn't do, so I'm going to move on to powers. We wouldn't be able to use this power function. So functions are basically different, they're like, they are literally what their name is. So functions are things that carry out pieces of code. In this case, this int main function is running our entire program step by step. So what is int main doing so far? Well, it's executing these 3 lines of code. If I wrote these out of int main, none of these things will be executed, alright? So CMath allows us to have these little mathematical functions instead of just being limited to plus, minus, division, and multiplication. So now that we have the CMath module, we can do everything that's in it. We can even do cosine, we can do tangent, we can do sin, we can do cos x, we can do all kinds of more complex calculations if we import the include CMath package. So the power function takes in 2 arguments, the base and then the exponent. So all I need to do for now is raise x to the power y. So if I raised x to the power y, the computer would look at x, well x is equal to 9, look at y, and we can change this back to an int because it's not division. You can remove the 0.0. Alright. So pow xy, so x is the base, where the second argument, so the first argument we're giving is x, and basically what functions can do is they can take in arguments. So you can take like an argument 1 and an argument 2, and basically what it will do, function will do, is it will do something with those arguments, and then it will return that code. In this case, the int main function is returning the value 0. We don't need to include that, but you can just say that. It's returning an int. So we'll explain that functions too, what they return is what their type is based off of. There's also something called void, which we'll get later into. So now, what the computer will do is it will see that it's raising 9 to the power of 2, which is, so in case what we need to do is if we always want to square a number, we can use the power function and always make the exponent 2. We can just write that constant. We can just say int squared, and then we can equal that to be 2, and then it will always raise it to the second power. Therefore, we can use the power function to only raise x to the power square, and that's how we can create constants. That's like a funny little thing to do, or a neat thing. Basically, what it's going to do is going to raise 9 to the power of 2, which will give us, because it will look at x, which is 9, and y, which is 2. Therefore, 9 squared, 9 raised to the power of 2 is 81. Which is 9 multiplied by itself 2 times. On this, we should see 81. And that's what the power function does. It takes in 2 arguments, it takes in the base and the exponent. What it does is it raises the base to the exponent. So it will multiply the base by the amount of times indicated by the second argument, which is the exponent. And lastly, we can do all of these operations with floats. So if I were to run the power of x raised to y, even though these variables are not floats, it will still work. So this applies to any type of data type that references a number, and in this case that is floats and ints in the C++ programming language, or also known as doubles. but we'll keep it as doubles because floats have extra precision. So we can also so whatever we did with the ints, I'm just going to show you guys that with the doubles. So you just add them together, subtract them, multiply them, and since they're doubles, we don't need to change anything when we're dividing. Oh, my bad. Alright. And that was it for my video, guys, and this video, guys, and hope you guys enjoyed the video. If you liked it, hit the thumbs up button. If you really liked it, how I explained everything, make sure to hit the subscribe button for some more awesome content coming up in the playlist and to be a part of the Legendary Code family. So, also, share this to as much people as you can if you enjoyed the video, to try to reach out to people who are new to programming or already made programmers, right? So, that is it for this video, and I hope to see you guys in the next video.